In this example, we're asked to find the indefinite integral for x minus 1 over root x squared minus 2x dx. Noticing here that the derivative of x squared minus 2x is 2x minus 2, a multiple of the numerator, tells us that U-substitution is the procedure we'll follow, setting u equal to x squared minus 2x. That fits the pattern that we have mentioned a few times, where letting u equal the term with the greatest power of x makes sense because the power is reduced when we take the derivative, as it is here with 2x minus 2 dx. Substituting then in for u, we need to remove the 2 to give us the numerator, and doing two steps at once here, we can take the half outside from du over 2, leaving du over root u. Now we can integrate with rule 1. U to the minus half becomes u to the half over half plus a constant. In this case, the half cancels with the half, and we're left with root x squared minus 2x plus c. As with all integration questions, we can check this by taking the derivative here and making sure we get our question back. Quickly considering the derivative, bringing the half out front, the root part is going to end up in the bottom because it'll have negative a half as the exponent, giving us this. The derivative of the inside, 2x minus 2. The 2's cancel with the half that we would have brought out front, giving us the integral that we expected. In this example, we have a product rather than a quotient, but we're still going to pick the polynomial or the linear or quadratic or cubic term, whichever you get, with the highest power of x, so the largest degree polynomial. So here, u is 1 minus x cubed, and du is 3x squared dx. So 6x squared dx we have in our question. Here we only have 3, so we need 2 more. So one way to do that is to multiply both sides by 2. So 2 du is 6x squared dx. Now making the substitution in our question gives us the integral of 1 u to the 4 over 3. 6x squared dx becomes 2 du, so we stick 2 out front using rule 2, put the du, integrating gives us 2 u, add 1 to 4 over 3 is 7 over 3, over 7 over 3, plus a constant. To simplify, the 3 comes up, that gives us 6. U is replaced. Exponent stays the same. 3 came up, that left the 7, plus a constant. In this final example of U-substitution, we have a product of two terms, one with an exponent. So if U-substitution is going to work, this has to be u. This is also the highest degree, and the derivative is indeed a multiple of x squared minus x, so U-substitution is fine. U equals x cubed minus 3 over 2 x squared du equals 3x squared minus 3x dx. 3 is extra, so we can divide by 3 to give us x squared minus x. dx, which is what we have in our integral. Here's u, and we end up with 1/3 from the over 3 times or the integral of u to the 8 du, which is 1/3 u to the 9/9 plus c. Simplifying then gives us x cubed minus 3/2 x squared, replacing u, that's to the power of 9/27 plus a constant.